X is a function for which this integral property is true, and we're asked which of the following claims about f of x are necessarily true. So the integral, which ones does it imply? What we're asking here. Now, a key idea that we're going to use in this question is the fact that this integral must be greater or equal to 0. I'm squaring a function, so it's going to be positive or 0, and then I'm integrating it. I could never get anything below the axis, because it would look like this. At worst, it would go down to 0, then back up. It can't be negative. So let's use that. I'm just going to rearrange the integral, so it's 0 to 3 of f of x squared dx equals the 0 to 1 of f of x dx minus the integral 0 to 3 of f of x dx. And like I said, this here is greater or equal to 0, which means this must also be greater or equal to 0. And I can rearrange that to give me the integral from 0 to 1 of f is greater or equal to the integral from 0 to 3 of f. And actually, that is statement 2. So statement 2 is necessarily true. Okay, then we just got to look at statement 1. Well, for this, I'm going to take the integral and combine it. So I can write this right-hand side. Let me just write it out again. Might be a little bit easier to factorize out a minus and have the integral from 3 to 0 of f of x dx minus the integral from 0 to 1 f of x dx. And so if we integrate from 0 to 3 and then subtract the integral from 1 to 0, this is actually going to be identical to the integral from 1 to 3. Because think about it. If I'm finding the area between 0 and 3, but then I am subtracting the area between 0 and 1, we're going to be left with the area between 1 and 3. It's a little bit more clear. And then, can f of x be less than or equal to 0 for some x between 1 and 3? Well, the answer is yes, because again, we know that this is greater or equal to 0. So if this was always positive, there's no way that we could get a positive answer overall. Okay, the function could be 0, but otherwise it's going to have to be negative somewhere to make this work. For this, what we're saying is for this whole thing to be positive, this thing must be negative. This is another way of explaining it. And therefore, at some point, the function must be negative. So actually, both of the claims are necessarily true. Our answer is D.